Welcome back, everybody. This is episode 5, I do believe. We've done front 1, 2, 3, 3.5, and 4. So yeah, this is episode 5. And today we are adding sprites, lasers, I should say. Wow, that was bad. Okay, we are. Sorry for a bad intro. We are basically today creating the ability for the players to shoot lasers at each other. We aren't going to be adding in the ability for the lasers to actually collide with and injure the players because that's more code. Right now, all we are doing is making sure that we are able to shoot a laser. So in order to do that, we're going to create a new file, new Python file, and call it laser. Now, like I always like to do, I'm going to move laser to the end of the player function and get ready to start adding some code here. We need to import PyGame. Just as everything we use needs PyGame. And I don't actually think we have any other imports we need to create. So the first thing that needs to be done here is, well, I guess we don't even need any groups, we can just go straight into creating the class. So this is going to be creating a class called laser, but we're actually going to pass it something that's not object. Not object. We're going to be going pygame.sprite.sprite here, which is a class constructor for a Pygame sprite. Now, we need our init function, and what do we need for laser? So we're creating a laser. It's going to be a Pygame sprite, and it needs a starting x position, a starting y position, and then if we're making it a graphic, we need a width and a height, right? So we need an x, a y, a width, and a height. I'm also going to pass it, instead of a width and a height, simply a direction. And I'll explain to you why we do this direction in just a moment. But, unlike our regular init statement where you just start self.x equals x, like that, we need to do one more thing first. We need to say pygame.sprite.sprite.init self. Now you notice that init is no longer, if we don't have this, you'll see the init function's old. It's missing its superclass, right? It's old, messed up. So we need to make sure that we initialize the sprite around self, because sprite is a class. Laser is basically a child class of that class. So that's what we're doing here. We're creating a child class. So you have to initialize the parent class inside of the initialize function for the child class. And sprites and classes and binding classes to each other like this aren't very easy to do. I'm not even very good at explaining it. I just know how to do it. If you want more help on this, or you want me to go more in depth with this, let me know in the comments below. Again, with any video, if you want me to explain something more, if you want me to go deeper into something, anything like that, let me know, and I'll do my best to dig into it, do a little bit more research on my own, and make a video for it. Anyways, our next step here is to go through and finish the class like we would any normal class. So we need to bind our x and y values. Whoa, that was weird. Why is it doing that? So it doesn't like the name direction, or dir. Apparently, dir's already a function. Anyways, so we've got a direction. Now we're going to create a if statement that's going to decide our x and y, because the direction's either going to be moving along. Well, I'll show you like this. If the laser is being fired in this direction, it's going to be a rectangle that is shaped more like this. However, that is also true for this direction. It'll just be moving the other way. If it's moving up, it's going to be a rectangle shaped like this. And that is also standing true if it's moving down. So this is what we're using our directions for. If it's one of these two directions, give it a width and a height that matches this. Otherwise, if it's in this set it up likewise. So let's start that. If self dot direction is equal to 0. Now let's figure out what we want our 0 to be. I think 0 should be up, 1 should be right, 2 should be down, and 3 should be left. So if we're doing that, where 0 is up, we can say equals 0, or if, well, or self dot direction is equal to 2. So if it's up or down, let's create our self.width and height variables and set them both to 0. Just like we've done in our other class over here, we've created our mx and our my and our width and our height, and we've set them to something instead of just naming them and setting them to these. So we can say self.width. So if we're moving up, our width isn't going to be as much. I say 5 is a good number for this. Oh, actually, since we're working with 32s and not 20, we'll go 6 here. And our self.height will be equal to 12, because it's going to be a taller, skinnier object. Maybe 16 here. It's taller and skinnier because it's moving up or down. Elif self.direction is equal to 1, or self.direction is equal to 3. So now if we're moving laterally across either positive or negative x, self.width is going to be our 16, and self.height is going to be equal to 6. So we're just flipping those values so that we're wider now and not nearly as tall. Let's go in and add our pseudocode here. So here we are creating a class. Here we are creating the class constructor with a width, or sorry, with an x, y, and direction. And here we are initializing the parent class of PyGame.sprite.sprite. We are binding the x value to the class, and we are binding the y value to the class. This is actually a good way to write your pseudocode. If you write a little bit of code and then step back and think, okay, what did I just do? You can step back, look at what you've written, and write all your pseudocode after the fact. So I know here we had to create a width value and create a height value. This direction is binding the direction value to the class. That's what we did. So it's a good way of kind of checking your code, because then you can look at it and go, okay, so what does this line do? Oh wait, that's not right. This is what I wanted to do. So we say else if self-direction is equal to 1 or 2, and I read through this and go, wait, I wrote that wrong. This is supposed to be a 0. You can catch your mistakes before you actually run the code. So we are here checking if the direction is moving in the y-axis, is basically what that is. And what is this? I guess setting the width to the vertical value and setting the height to the vertical value. So if we're moving it along our vertical axis, that's what we're doing. Here we're checking if the direction is moving in the x-axis, and if so, we are setting our width to the horizontal value and setting our height to the horizontal value. That makes sense. Now, it is a sprite, so we need to give it an image. Self.image equals pygame.surface, just like we did with our player. And the surface needs a width and a height. So self.width and height. Now, in order to be able to fill this in, we actually need to add one more object to our constructor, and that'll be color. We'll put that in right here underneath direction. Self.color equals color, and it will be binding the color value to the class. And then we are creating the image with our width and height. And now self.image.fill. We need to fill in the image with our color. Now I'm moving a little bit faster in this one because we're writing a class, and a class is something we've done before. So I'm willing to move a little bit faster when we're working on something that we've done before. fill the image. Really quickly, I want to make sure we're still recording. Yes, we are. Okay. I usually run 2 monitors at home. I'm not at home right now. I'm actually in Buse's office during Flex, I think. Yes, because it's 9:46. I'm in Buse's office during Flex. Because I have so much crap going on, I can't record at home. Anyways, so I'm willing to move a little bit faster through some of these videos in which we're doing something that we've done before. So in this case, we are creating a class, which we've done for our player right here. We created this object class. Now, this class for the laser is going to be a little bit longer, but not by much, because we're almost done with that, actually. Our last thing to do in our initialize function is self.rect. And this is something that's required. I don't know if we did it in the player, did we? No, we didn't, because we just used an image. So in this case, we're creating a surface which requires a width and a height. That is going to be a microsurface similar to our screen that's going to be displayed at a position. That position is our rect, so self.x and self.y. So this is basically, this is creating an instance of the class at the x and y positions. That's what we're doing there. Now, let's create our update function. And watch how easy this one is. We simply want to update our position. Beautiful. Look at that. That's basically the finished class. Now the only thing we're missing here is the fact that we need to be able to make these lasers move. So let's go ahead and create a speed value up here. Self.speed. And I'm going to set it to 15 for right now. That's going to be a pretty decent speed. And we've got a direction right here. So we need one more of these direction loops, right? This one's going to be a little bit different. Right down underneath the first one, let's start writing. If self.direction is equal to 0, we need to now start changing. And with the player, if we wanted the player to move up, we would modify its move x or its move y value and make it negative. So let's add a move y and a move x value up here. Self.mx equals 0. Create a movement value for the x. Self.my equals 0.
All I need to do is override Control Alt and Delete.
There you go.
So now that I have a running virus that continuously reopens itself.
That is awesome.
It's like I will destroy your RAM.
Kason just created a virus in Python and PyGame that actually overrides the computer and keeps you from putting any kind of input in. The only way you can get out of it is using the Control-Alt-Delete keys to close the window, and he's just managed to fix that, so you can't actually override the virus anymore. So that's pretty awesome. That's kind of the more evil side of using PyGame, if you will. Anyways, where were we at? We're creating a movement value for the y. There we go. And our speed is going to be a constant speed value. Now, where were we at? Down here. All we did is create an mx and an my, which we worked with in our last class, and a fixed speed. So now down here, if our direction is equal to 0, that means we are, if we want to move upwards, or shoot upwards in this case, self.my equals negative self.speed. So self.speed in the negative direction. Make our laser move in the negative direction. Elif self.direction is equal to 2. That's positive, right? If we are shooting down. Self.my equals equals self.speed. Make our laser move in the positive direction. Now remember, positive y is moving down towards the bottom of the screen, so it's a little weird. And of course, this might seem weird, self.my equals negative self.speed, make our laser move. It's because we haven't added our self.y plus equals self.my, so that won't actually do anything yet. We're just trying to write the end of this loop. Elif self.direction is equal to 1, and that's going to be moving to the right. If we are shooting right, self.mx equals self.speed. Shoot right, basically. And last but not least, if self.direction is equal to 3, which is if we are shooting left, then self.mx equals negative self.speed. Shoot left. There we go. Okay, so that's a longer loop. It's a ton of if statements. But basically what we're saying is if our direction is equal to 0, we are first off setting our width thin and our height tall. So we're setting our object up. If our direction is equal to 0, then we are doing this. If our direction is equal to 0, we're setting our object to look like this, right? It's moving in the upwards direction, which is 0. And then we are giving it a speed fixed to this, which is equal to our speed value, in this case 15. So we're not actually moving it yet, we're just setting up, first off, its width, which I really suck at drawing with a mouse pad, and its height. And then we're setting up its speed, which is in the action that the axis is moving. The only thing we have left to do to get this actual object moving is to say self.x plus equals self.mx and self.y plus equals self.my. And it's the same thing, update our y position, and update our x position. This is the exact same thing that we did in our player class. Right? Over here in our player class, update our x and update our y. So our sprite is almost ready to go. The last thing we have to do isn't actually in the laser class, it's in the player class. Inside of player, we need to import laser. We can do that. Import our own file. I don't know if we've actually done that anywhere, because we never had to import data into player, but you can import files into more than just your original file. You can take the player file and import data in laser if you want to. Anyways, we're going to pull in the laser file, and then, let's see here. Let's say we have a shoot function. Def shoot. And this requires a direction. And that's it. So all we have to do is pass the direction. Now, that will be trying to figure out the simplest way to write this part. Okay, so before we do that, this will make it a little easier. We need to create something that can hold a sprite, which is called a sprite group. So self.lasers equals PyGame.sprite.group. So this is a group for our lasers, basically. Groups are how you draw and render large amounts of sprites at once. So we're creating a group. Now we want to say, what's the best way to do this? L equals laser.laser. So let's create a new laser, because we're calling the laser class, and now we want self.x is the x. Actually, we want the int of self.x plus self.width divided by 2. So we're trying to grab the center of our x. We also want for the y value the int of self.y plus self.height divided by 2, so we get the very center of our object. Then we need a direction, which in this case I'm going to say self.direction, and then we need a color, self.color. Let's come up here really quickly and add self.direction equals 0, just for testing purposes. So we've created an object called L. It is equal to the laser file, the laser class, and we are creating an int at our width divided by 2, our height divided by 2, and moving in the positive direction. Now, all we have to do at this point is, actually, we'll do this. we will do... This is getting to be a pretty long...
Justine Ruff, please come to the office.
Okay.
Justine Ruff, please come to the office.
We're going to just say self.lasers.add L. And then every time here, let's shoot. Let's call self.shoot. So all we've done right now is made it so that basically, requires a direction. What did I mess up? Oh, yes. Shoot, self.direction, and then change this to just be direction. We should just be shooting a ton of lasers straight up. No, we're not, because we're not drawing them yet. So, let's pass a surface value here, and say self.lasers.draw surface and self.lasers.update. And I'll explain all of this in just a second. I just want this to work really quickly. And wherever we're calling the update player screen, we need to pass to both of these. Alright, now we should see, there you go, we've got a ton of lasers being shot straight up into the air, and they look really weird because they're being shot so close to each other you can't actually tell the difference of them. If we're running around a little bit, you can see where they're at. Anyways, I'm going to end this one here for now, and come back with part 2. So this will be 6.1, or 5.1, and there will be a 5.2 that comes up after this. And that will be everything for this episode. So we'll pick up right here in the next one, and finish our lasers, get everything moving in the right direction, and after that we'll jump into episode 7. So until then, happy coding.